All right, hello Algebra 2 students, and welcome to Chapter 2. We're going to be looking at linear functions in this chapter, and lines and slope and all that stuff that goes with it. And today in Lesson 2.3, the objective is to be able to graph linear equations and to write equations of lines. So it should be mostly review for you, but we'll see where we're at and we'll go from there. Okay. So if we start off here, I asked you to describe slope using words. And the main thing that I want you to understand about slope is that it is really just a rate of change. That's what it is. It is a rate of change, okay? And so it describes the steepness, if you will, of a line, okay? It describes the steepness of a line, but really this is the way that I want you to understand it, is it's a rate at which things are changing. And the line is usually coming from some set of data where we're comparing two things. So we're looking at how fast the change is between two different variables normally. So that's your first part. So here's some quick examples to kind of give you an idea. So if you buy 10 gallons of gas for $40, what's the rate of change for gasoline? Okay, it'd be $4 per gallon. That's a rate, that's a slope. Okay, you are paying $4 per gallon. The per meaning like the division portion. Number two, if you go through and you go up 100 steps in an hour, what's the rate of change for steps per minute? Okay, so that means you'd be going 100 steps per 60 minutes, so it'd be 100 per 60. Okay, or if you reduce that, it'd be 10 over 6, and that's your rate per step, if you will, okay? Or steps per minute, I should say. So slope is more than just rise over run, okay? Like I said, it's an idea of rate of change between two variables, an independent and a dependent variable. The rate of the dependent changes against the rate of the independent, okay? So it's always comparing those two things. So it's just another way of thinking of slope. And now that we're in Algebra 2, we're going to try to deepen your understanding of what slope actually is, so you don't just think it's rise over run or y1 minus y2 over x1 minus x2 or something like that. We want to make sure you understand that it's a rate of change. Okay, so if we go on to the next slide here, there's 4 different types of slope. Okay, the first 2 you're probably very familiar with. As we go through and we take a look at this, get rid of that. So first one is there's a positive slope. As you work from left to right, you are going uphill basically, or up the steps. So that's one example. The second one is that it is a negative slope. Okay? If you're skiing downhill or something along those lines, that has a negative slope. It falls as you're going from left to right when you're looking at it. And then these two I put in a kind of a box because of the fact that they're kind of the special case. Number 3 is that you would have a zero slope. Okay, and one of the things to bring back again, if you remember back to the whole Hoy and Buck's idea, okay, well, a horizontal line, that's the Hoy idea that we're talking about, that you talked about back in Algebra 1. So this would be a horizontal line, has a zero slope, and a y equals some constant equation. Okay, so y equals 5 would be an example of a horizontal line. Then the other part that we have is we have an undefined, a vertical slope, okay? And that goes back to the idea of, that's VUX, if you remember back. And what that stands for is the V stands for vertical lines, the U stands for undefined slope, and the X stands for that they have X equals equations. X equals 2 is an equation of a vertical line. X equals -5 is a vertical equation, okay? So those are the different types of lines that you're going to be taking a look at. Positive, negative, zero, and undefined. Those are the different types that we take a look at. So if we keep going, here's your different equations of lines. The one that you're probably most familiar with is this one, slope-intercept form. This is the one we're starting off with. This is the one you use the most often. And one of the things you always do is you try to put it in y equals form, okay, where you're trying to get it. Then you can very quickly look at what the slope is and what the y-intercept is. So if we go down here, M and B, what do they stand for? If you remember back, M is your slope. Just one quick note, a common mistake that people make. Remember, the slope is just a number, okay? And you can think of it in terms of a fraction, but it's just a number. It is not the number with the x. It's the number in front of the x. And I've seen in the past, I remember last year in geometry, a lot of times students would write down that the slope was 2/3 x or 3/4 x or something like that. There is no x. It's always the number in front of the x. And then b is your y-intercept, okay, where your graph crosses the y-axis. So that's the b value. Remember, when you graph a line, you always start with a point. So in this case, you start with the y-intercept, you plot that point, and then from that point, you use your slope, okay, to find other points. So if we take a look, when we say what is an intercept, just in general, we can talk about that in terms of both x and y intercepts, but generally an intercept is where the graph crosses an axis. Okay, so it could be the x-axis if it's an x-intercept. It could be the y-axis if it's the y-intercept. And if you think about it, the y-intercept, okay, is when x equals 0. Okay, it's always when x equals 0, because of the fact that every point, if x didn't equal 0, you'd no longer be on the y-axis. You now would be off of the y-axis at +1 or -3 or something. And the same thing goes for the x-intercept. The x-intercept is when y equals 0. And it's for the same reason. If y equals 0, that means you're on the x-axis. If y equals some positive number, now you're coming up off of the x-axis. Or if it's negative, then you're going below the x-axis. So the main thing I want you to remember is an intercept, whichever intercept you're going to be finding, the opposite variable is always 0. Okay, so that's an intercept. So now if we take a look at a couple of different examples, we want to write the equation of a line given the slope and the y-intercept. One thing I want you to notice right away, x equals 0 for that y-intercept. And so in this case, this one should be fairly straightforward. Y equals my slope of 1/5 x, since my y-intercept is negative, we put that as a -3, and there's your equation of your line. Y equals 1/5 x minus 3. If we keep going, example number 2 here, let me bring that back. We want to rewrite this in slope-intercept form. And one of the things I want you always to remember is slope-intercept form is really y equals form, which means if you want to put something in slope-intercept form, you need to solve for y. So I'm going to put a box kind of right around y in this case, similar to like we did when we were solving literal equations. And so now I need to get that y by itself. If you remember when we solved literal equations, I told you kind of 2 ideas. Get the term by itself first. So I want to make sure that this term right here, this -4y, I want to get that by itself first, which means this 5x has got to go. So the first thing we're going to do is we're going to subtract 5x. Those will cancel out. We bring down the -4y equal to -5x. 16 is positive, so it's a +16. And now that the term is by itself, now I want to get the y by itself. So now I need to get rid of the -4. Okay? So get the term by itself is step 1, then get the variable by itself is step 2. So we are going to divide everything by -4. Okay? Every single piece here, every term gets divided by -4. Those cancel, and we end up with our equation of y equals negative divided by a negative is a positive, so this becomes a positive 5/4 x. Positive 16 divided by -4 is a -4. And there's your equation of your line, and now you could go ahead and graph it using your y-intercept and then your slope. Okay? If we take a look here at example number 3, here I'm asking you to kind of do just that, is to go through and graph this. And for now, what I'm going to have you look at is change this into slope-intercept form, and then we'll graph it. So once again, if I'm solving for y, I want to get in y equals form. That means the -2x right here needs to go away. So we need to move that to the other side of the equation. So I'm going to add the 2x to the other side. Okay, when I do that, those cancel out, and I end up with y equals 2x plus 1. Okay, so there's my equation, and so now my slope is 2, or we can think of it as 2 over 1. And my b value, my y-intercept, is positive 1. Okay? So, remember we start off with a point. So right on the graph here, I'm going to start off with, there's my y-intercept of 1. And then from that point, I'm going to use my slope. Remember, rise over run. Okay, my rate of change. So we are going up 2 over 1. There's my next point, another point that I know is on the line. I can do it again. Up 2 more over 1. Up 2 more over 1, and we can go with that. I could go the other direction. We could go down 2, but then left 1. Down 2 more, left 1, and so on and so on and so on. Okay? And then we can go through and draw that line in as we work our way through it. So let me go through and do that. And so now, if I, well, let's just draw it in. Let's make this easier. So now if I draw this in, there is approximately what my line looks like for y equals 2x plus 1. Okay? Make sure you draw in the line, because if you just put the points, that's not an equation of a line. That's just some points that are on the line. Remember, there are points in between these points that are the not so nice ones. We don't want to have to worry about trying to plot those, so we plot the nice ones, but then we got to account for all the ones in between by drawing in the line. So make sure you do that, but don't forget the line. Don't just put dots down. Okay? So then, in this case, if you went through and I want you to try this, so what I want you to do is I want you to pause the video here, and I want you to actually try doing these 3 different problems. Okay? Let's put it here so you can actually see it a little bit better. I want you to try these 3 different problems on your own, and then I will come back and we'll go over them real quickly. Okay? So pause the video, give it a shot. Okay, let me come back and we'll go through this fairly quickly. First one, I asked you to write in slope-intercept form. Remember, we're solving for y. So step number 1 means I need to get rid of the x. We're going to move that to the other side. Okay, and I'm going to kind of come off to the side here. So that means I have a negative 2y, don't forget the negative, equal to a negative x plus 1. Now I need to get the y by itself, so we divide everything by negative 2. And in this scenario then, we end up with y equals 1/2 x. Okay, there is a 1 in front of the x. Negative divided by negative is positive. And then we end up with a negative 1/2. And there's your equation of your first line in slope-intercept form. Okay? What we started with, just to kind of give you a heads up, this is what is called standard form. That's something we're going to look at in the next lesson, but that's where we're at. Okay? Finding the slope. So if you remember, slope is, like we said, rise over run, or we can think of it as a change in y over change in x, or we can think of it kind of as coordinates, y minus y over x minus x. Okay, so if we do that, what I'm going to do is I'm going to go through and look at change in y versus change in x. So in this problem, I'm going to look at the y values. And what I'm looking at here is from negative 3 to positive 1, what's that change? Well, to get from, and I'm thinking on a number line in my head is what I'm doing. So negative 3 to a positive 1, that's a change of positive 4. That's my change in my y coordinates. Over, now I'm thinking about negative 1 to positive 3. Going from negative 1 to a positive 3 on a number line, that is a change of another positive 4, which now if I reduce, that means I've got a slope of 1. Okay, so that's the idea. You could also go through and subtract y coordinate minus y coordinate and do the math. Just be careful that you always start with the same x and y coordinate, that you don't flip them around, because otherwise your signs will switch. And then down here on number 3, the last question I have for you is, why is the slope of a vertical line undefined? And so if we take a look at this, and we think of this as change in y over change in x, okay? So the slope, the change in y, I could go through and I could pick any 2 random points and we'd have some number, okay? I'm going to make something up. Let's say it's 5. That's my change in y. But with every vertical line, if you think about the change in x, there is no change in x. There is 0 run, which is exactly why this slope is undefined, because remember, we cannot divide by 0, and so that is the reason why this is an undefined slope. okay, because we end up having a run of 0. There is no change in x. So hopefully that gives you a kind of a refresher on what's going on. Your practice to learn for this one is the 2-3 worksheet. Go through, work your way through that, and bring that with you to the next class, and we will go over some questions from that. Okay, good luck, everybody. I hope it goes well.